Hello, everyone. Welcome to AP Statistics. Today is 9/26/2018. We'll be doing this example on Chapter 8, Quiz B. All right, let's begin. Hey, I'm recording. Mean students. All right. I know, that was the whole point. Mean kids. All right, so we have some data, and we are going to look at all the steps to run a linear regression model. So again, tomorrow, you will have to do this by yourself for a grade, for a quiz. Okay? So you'll be given data, you're going to type it in, do everything we do right now. Okay? So let's go ahead and make thank you. A scatter plot. So we have all our data. Doc, insert, data and statistics, number 7. Do you think that the time / year, the year explains the postage rate, or the rate explains the postage? Or the rate explains the year? Okay, so we have year on the X, and on the Y we have the postage rate. Okay, so every time we make a scatter plot, we always have to think about what? Not shape. Direction, form, and strength. Direction, form, and strength. So there is a, let's write it down. Because notice in number 1 it says make a scatter plot, but also describe the association. Okay, so there is a positive, or linear, strong association. And if you want to get full credit, you must put this in context. So between year and postage rate, or postal rate. I don't even know how much it costs for stamps, because I use stamps so infrequently now. Does anyone know what it costs to get stamps these days? Is it 25 cents a stamp? I thought it was higher. I thought it was like almost 50. 40. Last time I bought it was like 5 years ago, and it was like 43 cents. So I figured it was only gonna go. But anyway, I just go to my wife. Do you have a stamp? And she's like, yeah, I have a stamp. She always has stamps. I don't know. She does. She has those like forever stamps. Yeah, that's it, she said. I'm sorry you said that. At dinner tonight. I do call it din din. Nice, you too? Nice. Huh? We subscribe to each other. Yeah. After dinner, we put the family on the couch and we just watch math videos. We don't. But I explained something to Henry yesterday, or Catherine. I explained something mathematically to Catherine the other day, and it doesn't mean she doesn't understand, okay? And then I hear from downstairs, Molly be like, she doesn't know what that means. I'm like, I don't care, right? I'm just trying it out. I forgot. It was something mathematically. I'll remember today. All right. They're like, I'll be putting it to bed. I'm like, oh, that's what it was, Okay. So, when you finish this process, all right, because remember, right now we're still like in chapter 7, just thinking about whether we can continue with this model. If you write linear, is it appropriate to continue making a linear model? Yes, right? We want it to be linear. If it's not, we cannot run this linear regression model. So I'm going to go to Doc, Insert. I'm going to insert a calculator page, number 3. Joseph, do you need a calculator? In the future, just tell me, like, from the get-go, because I have an extra. I got 2 extras. Which one?
That one does not.
So bottom one? There you go. Bottom, no, sorry. There you go. Yep, you got it. If it doesn't work, try this one. Okay. Menu. Statistics. Stat calculations. And which one are we going to choose? Linear regression, A plus BX. So remember, you're not in algebra, so it's going to be A plus BX. Okay, what did we say our explanatory was? Year. And our response is rate. Notice it's in F1. If we want to use this later, the equation is going to be in F1, and I'm going to tab all the way down and hit OK. All right. Now, what did we describe the strength as? Strong. When you look at R, does that R, bless you, does that R make you think, yep, I feel good about using the word strong? Yeah, it's 0.995. That's really strong. And if you look at the scatter plot, you'll see that it looks, almost looks like a perfect line. All right, so that doesn't surprise me that we have a very strong correlation coefficient. So let's write down the model. See number 2? Let's write down in number 2 the model. Nice. What is our response variable? The rate. So we have rate hat. Somebody in my previous class asked, does the size of the hat matter? And I said no. So if you'd like to do like that big, I don't care. It doesn't matter to me. Okay? Equals. What is, it wasn't a good guess. All right. What is the y-intercept? Negative 0.64. Okay. Plus, what's the slope? 0.01 times. Now, I'm going to actually write year. Nice. Since 1900. So if I wanted to figure out, okay, what does the model predict the cost of a postage stamp is in 2018, you're going to type in what for X? 118, because that's how many years it's been since 1900. Okay? Everybody good on that? Okay, let's move to the back side. Go and flip it over to the back side. Number 3, do you think a linear model is appropriate here? Yeah. And so this, before you can answer, you should be like, I got to do something. Very good. So what I usually tell students to write down is really big, all caps, residuals. Okay? The idea is if you write yes or no, and you make no mention to the residuals plot, can you get full credit? No. Okay? You must check the residuals plot. And it would be really nice if you sketched it for me. Okay? Doc. Insert. Data and statistics again. We're going to use the same explanatory. So we're still going to use year. But now, you'll notice even as I did that, now instead of putting rate as the response, we're going to do stat dot residual. Whoa. All right. Now, does anybody remember what I think when I look at the residuals plot? I think, you're right, I think nothing, right? My hope is nothing. And I don't mean no dots. I mean no pattern, a cloud. That's what I'm thinking. What do you think? Is there a pattern here? So this is your decision, right? Your decision. How many other parts of this problem do they want us to answer? Like 5 more. So what do you think I'm going to say for this? There's no pattern. So when I write down my answer, I'm going to write down, yes, the residuals plot shows no pattern. Now, this is up to you, right? You guys might have different views on this than I do. And you can get full credit as long as you don't contradict yourself. So if you write, yes, the residuals plot shows a pattern, you've contradicted yourself. If you write, no, the residuals plot shows no pattern, you've contradicted yourself. So you'll get points off. Okay, but if you write, no, the residuals plot has a pattern, then you can still get full credit. Everyone see that linkage?
Does that mean You wouldn't answer the other question.
Bold decision, right? You're going to have a quiz tomorrow. What do you think I would recommend all my students to do on the quiz tomorrow? Answer all the questions. So if this happens tomorrow and you think there's a pattern, you can say, no, the residuals plot shows no pattern, but I would still like for you to answer all of these questions. Okay? Now, if this was real life, would you do that? You wouldn't. All right? But tomorrow, answer them all.
So if it shows no pattern, or if it shows a pattern.
We shouldn't use the model. It's not appropriate.
In the AP test, what do you do?
In the AP exam, again, you can look to see what they're saying. You can also, what you can do in the AP exam is say, I don't think I should continue. I see there are a lot of questions, so I'm going to answer them, but I'm going to write down, I think it's not appropriate, so I wouldn't do any of this, but I'm going to do all the work you're asking me to do. That kind of thing. Okay? You can write it. It's humans that read it, right? It's not computers. Humans are reading it.
Okay, so no pattern.
Yes, no pattern means you can use the model and it's appropriate. Now, did I say it's a good model? I never said it's a good model. I just said it's appropriate. You can use it. We're going to answer a question later on that will quantify for us how good it really is. Okay, and Luis is right. It's the R squared. Okay, shall we continue? Excellent. All right, so number 4, interpret the slope of your model. Well, what is the slope? It was letter B, right? What is letter B? Was it 0.01? Excellent. Okay. So, what are we going to write for interpreting the slope? Let's ask Marcelo. The slope, B equals 0.01. What does that mean in context? Excellent. Marcelo's looking back at the previous problem. I love it. Do you need some help? Okay. Who would like to answer for us? George, give it a shot. Listen, Marcelo.
Like after every year, like the price of stamps will increase by 1.
There you go. That's what. So Marcelo, how would you answer it then? Every year. By? That's in dollars, so we could write by $0.01. I'm going to write by 1 cent. Very good. Good job, George. Good job, Marcelo. Every year, the price of stamps goes up 1 cent.
I thought we were supposed to write can be expected.
Oh, yeah, absolutely. Love those words. Again, this is a model, and I know that models are always wrong. But according to the model, I got you. Here you go. I got you. I got you. There you go. You'll like this one. According to the model. That better? Now you can sleep at night. Excellent. Okay. According to the model, every year the price of stamps goes up by 1 cent. And we know that's going to be wrong.
I heard yesterday that there was I forgot what it was, but you basically said you wanted to move it less than.
Yeah, so you can move it. You could say for every 10 years, then the price is going to go up 10 cents. For every 100 years, the price we expect to go up $1. Okay, that's all of those 3 are correct. All 3 are correct. No, you don't have to. For me, that makes sense, kind of. That's like 1 year, 1 cent, right? But like, what was the problem yesterday that I changed it?
R squared because you have.
No. She's talking. I know what she's talking about. She's talking about the slope. What did I do? What did I do it for? What was that problem that I did it for? It was yesterday. Was it the flight? Oh, it was the flight. It was like for every mile, it goes up 8 cents or something. So I think I made it 100 miles, and it goes up $8. That was just my preference, because like if I go 1 more mile, I mean, you haven't gone very far. So my thought is, okay, 100 miles, that's much further. So, but again, it doesn't matter. All are correct, as long as, again, you don't mess up when you do the movement. Does that make sense? Okay, now George, I think you're talking about when I write R squared, I always write a percentage. That's what I'm saying. All right? Okay, let's interpret the y-intercept. The y-intercept. Who wants to give that a try? The y-intercept. How would you interpret the y-intercept? Great, Jessica. What do you think? Well, I guess first, what is A? What is our y-intercept? Was it negative? Say it again. 0.64? Great. Okay? You don't know? Shall we ask someone for help? Ask somebody for help. Who would you like to ask? Like phone a friend. Jacob. Jacob, what do you think is the definition or interpretation of y-intercept for this problem? Very good. Year 1900, the price of stamps was negative 64 cents. Exactly, George. So when you do y-intercepts, sometimes they will make no sense. Write that down. This makes no sense. Literally, it makes no sense. I wrote it, yeah. I did. I should have wrote it in red. So like it's official until like you hit the X and it goes away. All right? So basically what we're saying here is that in the year 1900, you go to buy stamps, they say, hey, thanks for buying stamps. Here's 64 cents and a stamp. Right? Because negative means they're paying you. And that makes no sense. Right? I don't even know if they had stamps in 1900 because I wasn't alive. All you people back there think I'm old. My parents weren't even alive. My grandparents.
That was only 40.
My grandparents weren't even alive. Is that right? My grandmother's 93. Do the math. So if she was 100, she was born in 1918. Yeah, she wasn't even alive. So, ha!
See, you were born before your grandpa.
Almost a year.
Yeah, you. I will not take off points if you don't write that makes no sense. But it is okay to write the y-intercept makes no sense in this problem. That's fine. I write that on, yes, when I took the AP exam in 2003. Yeah, I must have been really old then. I would have written down in the year 1900, you go to buy a stamp and they pay you money and they give you the stamp. That makes no sense for this problem.
Maybe have it.
Sorry.
It's okay.
Okay. The clarification question.
I love questions.
It's just do you always set off to your starting point? So 900.
Well, think about back in algebra, right? With a y-intercept, your x had to be 0. So in this case, year 0 is not year 0. It's year 0 years since 1900. And what's 0 years since 1900? 1900. Okay.
That's why yesterday it was 0 miles.
Exactly. Exactly.
It wasn't.
Okay. Let's write down the correlation and finish off these last 3. Nope, don't need a bet. What is the correlation? R equals, still in red. Nice. I think it was 0.997, or what was it? 995. Thank you very much. 995, my bad. Might be. 0.995, which tells us it's strong. Right, it's very strong. It's almost 1.
You don't have to describe.
Nope, it just says, what is the correlation? Done. R equals 0.995. It doesn't say explain or, you're good. Now, this is where you will need to write a sentence. Explain the meaning of R squared. Well, let's first write down what is R squared.
0.98.
So I'm going to do a percentage. So I heard 98 point, so it's 99.0 then, if we're really rounding. 99.0%. Okay? Now the statement here, just like it was yesterday, is 99.0%. Oh, you know it. Of the change. Right is right, Nadia. Of the change. That's what I tell Catherine. Right is right. We're going to do this. Okay, Henry, we can do that because he can count. 99.0% of the change in postal rate can be explained by the year. And so since that number is really close to 100%, is there really anything else that goes into determining how much stamps are? No. It's literally just the year. Now I know nothing about postal rates and stamps and postage and all that. Okay? And maybe in, your lifetime, because I'll be dead very soon. Joke's on you if I really do die. That was weird. Good thing I'm recording for that. It got real. That'll give me some money. Yeah, GoFundMe. Yep. I was saying something, and I forgot. Oh, that you may not even have mail anymore. It might be all electronic, right? I mean, the postal service itself is already extremely declined. Exactly. Anytime I get something, yeah, but still, even if you recycle, it's still more time and money than if you would have just not done it all. Let's answer the last one, number 8. That's true. Who picks up the recycling? Trucks. Yeah. The trucks. And what are they using? Yes. Fossil fuels. Yep. So basically when you recycle, you're polluting our earth. Oh, man. That was like when I watched a video that somebody said that instead of the burning of fossil fuels causing the greenhouse gases to rise and climate change to be an issue, somebody argued that it was the other way. That it was because of the climate changing, that's actually causing us to burn all the fossil fuels. And that's what I said. I was like, no, that's not it. That's like the whole thing of like, you have lung cancer, so it's going to cause you to smoke. No. Okay, number 8. Oh, well, he's probably in class right now, just like you guys. He's at law school right now, so he's probably Mr. Haramian. He's in law school right now. He's probably in class, right? You guys are in class. He's in class. Crazy, right? Shout out! Yes, shout out! Subscribe, Richard. Okay. Hopefully you make bar review like my brother did at UT Law. Pressure. What are we doing? Number 8. Here we go. We are basically looking at residuals. Do you remember the formula to find a residual? I'm going to change it again. Probably not yet. Observed minus, I'll go with yours, predicted. That's fine. It's the same. Technically, I guess I wrote predicted first, so I'm going to go back to the original. But expected is fine. The idea is your predicted or expected is your model, and your observed is what they tell you it is. Okay? And so for every single one of these years, there is an actual postage rate, and there is a predicted postage rate based on our model. All right? The difference between them is the residual. Okay? Now, let's determine what's going to be more beneficial for us if we're going to buy stamps. So let's do an example. This would be a positive residual. A positive. All right? So that means, let's say the residual is positive 0.1. So 10 cents. All right? So if I have to write down a subtraction problem to get 0.1, what could I write down, Flory? What would be a problem I could write down for observed minus predicted that would give me 0.1? Flory. Start with an observed. Give me some type of postage rate. Anything you want. It can be as much as or as little as you want. 1 cent. This is going to be hard. Okay? Minus. What does this need to be to get 10 cents? That'll be a negative. Which we don't want to do that. Because it's not going to predict a negative. Let's try 50 cents. You could have done 20, that's fine. So what does this need to be, Flory, to get a predicted, or get a residual of 10 cents? Actually, 0.4 cents, because I'm saying 10 cents. This will make it easier to see. There you go. You see that? Okay? So, is this good or bad for us, a positive residual, as the consumer? Why do we say bad?
Because you pay more.
Because we're paying 50 cents, and the model says we should only pay 40. So we're overpaying based on this model. So positive residuals are bad for customers and good for the government. So we, as customers, want a negative residual. Storage Wars. War of the Worlds. World Cup. Can we keep going?
Or was he?
And then you gotta start with the last word. So cup. Cup runneth over. Over the moon. What is that? What? And Roberto ended the game. All right. You never played that game with your friends?
No.
No? It's a fun word game. I think it's time to stop the